Assalamu alaikum. So today in this video we are going to solve assignment number 2 of principal methods and applications of nuclear tracks. Okay, this is our assignment number 2. It consists of total 13 questions which we are going to solve in today's lecture briefly. So stay tuned with us. We are one by one solving each and every question step by step. So let's start. So our first problem is, given that the vertical etching rate VB equals to 4 micrometer per minute and horizontal etching rate VT equals to 8 micrometers per minute, what you have to calculate? You have to calculate the critical angle, which is denoted by theta c. As vertical etching rate VB is given, which is 4 micrometer per minute, and horizontal etching rate, which is VT equals to 8 micrometer per minute, you have to find critical angle theta c. You know the relation of theta c, which is equals to sine inverse of VB by VT. Just putting the value of VB, which is 4, and putting the value of VT, which is the horizontal etching rate, which is 8, and after taking sine inverse of 4 by 8 you will get 30, because theta and unit is degree, so your answer is in degree. So the answer is critical angle is 30 degree. Because in VB has same unit, VT has same unit, so units cancels each other, so you will only get with 4 by 8. Okay, that's why we not written the units, because units are similar, they cancels each other, you will only left with 4 by 8. So sine inverse of 4 by 8 you will get theta c equals to 30 degree, which is the critical angle. Now move towards the second problem. Second problem says that the critical angle theta c of an etching process is measured to be 45 degree, and the vertical etching rate VB is equals to 5 micrometer per minute. What is the horizontal etching rate? Means you have to find VT. So same procedure. Critical angle is given now 45 degree. Vertical etching rate is also mentioned, VB equals to 5 micrometer per minute, which is here. You have to find the horizontal etching rate VT. Same relation you have to use, theta c equals to sine inverse of VB by VT. Move, because we have to find VT, so first of all move this sine theta to other side, so it becomes sine of theta equals to VB by VT. Because we have to find VT, move VT other side and move sine theta to downside of VB, so VT becomes VB by sine theta. Putting the value of VB, which is 5 micrometer per minute, and putting the value of sine of angle, which is 30. Here you have to put 45. Okay, not 30, angle is 45 degree. Okay, sorry, by mistake. So here you can see the answer. After putting sine of 45 degree you will get 7.07 micrometer per minute. Okay, which is the horizontal etching rate. So this is how you can find the horizontal etching rate. So now move on towards our third problem, and our third problem is, in an etching process the vertical etching rate is 6 micrometer per minute. Okay, now the vertical etching rate is given, which is 6 micrometer per minute, and the critical angle is again given, which is 60 degrees. What is the you have to find what is the horizontal etching rate? Again you have to find the horizontal etching rate, mean VT. Same procedure, as you know that theta equals to sine inverse of VB by VT. Move sine theta to the other side, you will get with sine theta equals to VB by VT, because again you have to find the horizontal etching rate, which is VT. Move VT other side, sine theta divide to the other side, you will get VT equals to VB by sine theta. Just putting the value of VB, which is 6 micrometer per minute, and putting the value of sine and theta, which is given 60 degree. After calculating you will get 7 micrometer per minute, because the unit of vertical etching rate and horizontal etching rate is same, which is microminute per minute. Okay, as this unit. Okay, this unit comes here. So this is how you can find the horizontal etching rate VT if the critical angle and the vertical etching rate is mentioned. So now let's move on towards our fourth problem. Our fourth problem is, if the vertical etching rate VB is equals to 3 micrometer per minute and the horizontal etching rate is 9 micrometer per minute, what you have to calculate? What is the etching efficiency eta? Now the vertical and horizontal etching rate both are mentioned in your problem. You have to calculate the etching efficiency. How you can calculate the efficiency? Because you know that the relation of efficiency eta equals to, denoted by eta equals to 1 minus Vb by Vt. Just putting the value of Vb, which is 3, and putting the value of Vt, units are same, they both cancels each other, so you will only left with 3 by 9. So 1 minus 3 by 9, you will get 0.666. In percentage, eta is 66.6%. Okay, so this is how you can calculate the efficiency. Okay, now move on towards our fifth problem. Our fifth problem says that an etching process has an efficiency of 80%. Now the efficiency is mentioned, which is 80%. Okay, and the horizontal etching rate, which is Vt, is 10 micrometer per minute. What you have to calculate? You have to calculate the vertical etching rate, means Vb. Again, eta is given, which is 80%, and in value it is 0.8. Okay, after dividing 80 by 100 percent, you have to convert percentage, so eta becomes equals to 0.8. Okay, and the horizontal etching rate, which is mentioned, Vt equals to 10 micrometer per minute. You have to calculate the vertical etching rate, mean Vb. Again, you have to use the same relation of efficiency, eta equals to 1 minus Vb by Vt. Move this one to the other side, eta minus 1 becomes minus Vb by Vt, because you have to find Vb. Move this Vt, multiplies to the other side, so minus Vb becomes equals to Vt eta minus 1. Okay, putting the value of eta, which is 0.8 minus 1. Okay, 0.8 minus 1, what is become? Okay, 0.2. 0.2 minus 0.2 minus 0.2 multiplies by 10, it becomes minus 2, and here is minus cancels with this minus. Your Vb becomes equals to 2 micrometer per minute. Understood? This is how you can find the vertical etching rate, Vb. Now move on towards our sixth problem. Our sixth problem says that in an etching process, the vertical etching rate is 5 micrometer per minute, and the etching efficiency is again given, eta equals to 50%. What is the horizontal etching rate? Now you have to find the horizontal etching rate, means Vt you have to find. Vertical etching rate is given, Vb equals to 5 micrometer per minute. Etching efficiency is also mentioned, which is 50%. How you can convert this? By dividing by 100, you will get percentage into 0.5, which is the efficiency. You have to find the horizontal etching rate, means Vt. Again, you have to use the same relation, eta equals to Vb minus Vb by Vt. Move this minus 1 to the other side, eta minus 1 becomes equals to minus Vb by Vt. Multiply this Vt to the other side, so Vt becomes minus. Okay, Vt equals to minus Vb, and when Vt becomes upside, eta minus 1 goes downside to the other side, so eta minus 1, putting the value of eta minus 1, eta which is 0.5 minus 1. Okay, it becomes minus 0.5 divided by minus cancels, 5 divided by 0.5, you will get Vt equals to 10 micrometer per minute. So this is how you can find the horizontal etching rate if the efficiency and the vertical etching rate is mentioned. Okay, now let's move on towards our seventh problem. Our seventh problem says that the horizontal etching rate is 8 micrometer per minute. Okay, and the vertical etching rate is again given, which is the 6 micrometer per minute. What you have to calculate? What is the etching efficiency, eta? Again, okay, now horizontal and vertical etching rate both are mentioned. You have to find the efficiency. Again, you know the simple relation, efficiency is equals to eta equals to 1 minus Vb by Vt. Just putting the value of Vb, which is 6, and putting the value of Vt, which is 8, so 1 minus 6 by 8, you will get eta equals to 0.25. And when you have to convert this in percentage, multiplied by 100, you will get 25%. So the efficiency is 25%. Okay, now move on towards our eighth problem. Our eighth problem is a 5 grams charcoal sample from an ancient fire pit has carbon-14 activity of 63 disintegration per minute. Understood? And a living tree has a carbon-14 activity of 15 disintegration per minute per 1 kg. Okay, and the half-life of carbon-14, which is mentioned, 5730 years. What you have to calculate? How old is the charcoal sample? You have to calculate the age of the charcoal, means how long the time goes. It means you have to find the time in years, how long it is. Okay, So to find the time relation, how long the time goes, so there is the relation. You can calculate it by, you know, that t equals to minus 1 by lambda, where lambda is the decay constant, ln of r by r naught. Okay, whereas r by r naught is equals to rm, which is the molar mass. Okay, r is the disintegration per minute, and t is 1 by 2 is the half life, divided by r naught, which is constant, which value is 1.3 into 10 to the minus 12, ln of 2, and which is the mass in grams, small m, and Na is the Avogadro's number. Just putting the value of Ra, which is mentioned 63, disintegration multiplies by 12, which is the molar mass of carbon, because carbon 14 we have given, and the half life is which is given 5730, divided by R naught, which is constant, when the value of R naught is 1.3 into 10 to the minus 12, multiplies by ln of 2. Mass in gram is given 5 grams. Okay, multiply by 6.02, multiply by 10 to the 23, which is the Avogadro's number. Because r by r naught answer is in year per minute, you have to convert year in seconds and minutes in seconds. Years in second is 3.15 into 10 is per 7 seconds, and 1 minute has 60 seconds. So after convert, r by r naught becomes unitless, because the same ratio, so that's why they are unitless. After calculating, you will get 0.8840. Understood? So this is how you can find r by r naught. Now what you have to do now, just you have to put this r by r naught in this relation. Okay, and also you know that lambda equals to ln of 2 divided by t 1 by 2. After putting the value of lambda here and r by r naught here, you will get this. So here 1 by lambda, putting the value of lambda, it becomes ln of 2, t by 1, t 1 by 2 comes upside, ln of r by r naught. Now putting the value of half-life t1 by 2, which is given 5730, divided by ln of 2, multiplies by ln of r by r naught, which is given 0.840. Understood? After doing this, you will get your answer and your time, which is 1441 years. It means your charcoal sample is 1441 years old. This is how you can find the age, the time gone of any sample. Okay, any radioactive sample. Now move towards our ninth problem, and our ninth problem is the isotope of uh, K potassium 40 can decay either into calcium 40 and argon 40. Okay, assume both decays have an half life of 1.26 into 10 to the 9 years. The ratio of the calcium product to the argon product is 8.41 divided by 1, which is approximately equals to 8.41. This is the ratio of calcium to argon. This is calcium per argon, and it's equals to 8.54. Understood? The sample originally had only potassium 40. It is now has equal amount of potassium 40 and argon 40. That is the ratio of potassium to argon. Okay, which is 1 by 1. How old is the sample? Now again you have to find how old is your sample, means the time gone you have to find. So how you can find? Let's start. As the half-life is given, which is 1.26 into 10 to the 9 years, and potassium decays to calcium, and potassium also decays to argon, and their ratio is this, which is equals to 8.54. Understood? Now you know the formula of this T, which is equals to 1 by lambda ln of r by r naught. Lambda, you know that which is equals to ln of 2 divided by t1 by 2. So ln of 2, t1 by 2 comes upside, and multiply by ln of r by r naught, and the ratio which is given 8.54 divided by 1. So you have to put 8.54 divided by 1. So putting the value of half-life, which is 1.26 into 10 to the 9, and divided by ln of 2, multiplies by ln of this, you will get 3.86 billion years old. Understood? So this is how old your sample is. Now move on towards our 10th problem. And our 10th problem, what it says that an iron 49108 source emits a 633 kilo electron volts gamma photon and 606 kilo electron volts internal conversion electron from in the K shell. Okay, what is the binding energy of the electron in K shell? Now you have to calculate the binding energy. The energy of photon is given, which is gamma photon is given, which is 633 kilo electron volts, and the energy of electron internal conversion is also given, which is 606 kilo electron volts. We have to find the binding energy. You know the formula of the binding energy, which is the subtraction of gamma energy minus electron energy, conversion energy. So after subtracting 633 minus 606, you will get 27 kilo electron volts. So this is the binding energy. Okay, this is the binding energy in kilo electron volts, which is 27 kilo electron volts, and this is in the K shell. Understood? Now let's move on towards our 11th problem. And what's our 11th problem says that the Q value of an alpha decay. Okay, the Q value of an alpha decay of Pu 94 to 39, which is Q value is given, which is 5.25 mega electron volts. Okay, given the masses of polonium Pu, which is 239.052175 in AMU, and the mass of helium in AMU is also given, which is 4.002603 AMU. But you have to calculate the mass of uranium 92 to 35 in AMU, and the Q value is given. You know that polonium decays by this relation. Polonium decays into uranium 235 92 plus helium. Okay, and you know that Q value for the alpha decay is always parent minus daughter. So parent is polonium minus uranium minus helium. Okay, the Q value which is given. So if you want to find the mass of uranium, just move this polonium mass and this helium mass to the other side with Q. So mass of uranium becomes mass of polonium minus mass of helium minus mass of minus Q. Mass of polonium and mass of helium is given in question, and Q value is also given, but Q value is in mega electron volts. You have to convert Q value into the into AMU. How you can convert mega electron volts into AMU? You just have to divide 5.25 divided by 931.502. You can easily convert your AMU value, your mega electron value into AMU. So after dividing 5.25 divided by 931.502, you will get 0.0056360, which is the Q value in AMU. After subtracting, you can easily get the mass of uranium in AMU, okay, which is 235.043933 AMU. So this is how you can calculate the mass in AMU, okay, if the Q value is given. Now move on towards our 12th problem. And our 12th problem is, what is the maximum possible positron energy in decay of argon 1835? Now you have to calculate the maximum possible positron energy. Okay, you know that the positron decay, which is proton into converts into neutron plus positron E plus neutrino. Okay, because this is beta plus decay. And the Q value of positron can be written as mass of reactants minus this. Okay, minus parent minus daughter minus 2 mass of electron into C square. Understood? Now how you can find the Q value of this? So Q value is the mass of argon, which is, we know that 34.971, minus mass of chlorine, which is 34.968, and you have to multiply mass of electron by 2, and you know that mass of electron in AMU is 0.0005486 multiplied by 2, and you multiply it by C square, and the value of C square is 931.502. You can easily find the Q value, which is 1.77 mega electron volts. Understood? So the maximum positron energy, this is the Q value, and you have to find the maximum possible positron energy. The maximum possible positron energy is approximately the Q value. So the Q value is basically is the actual maximum positron energy. Okay, because neutrino carrying with negligible energy, because neutrino has no mass, negligible, so that's why their energy variance is no. So that's why the Q value is basically the maximum possible energy, and that is 1.77 mega electron volts. Okay, so now let's move on towards our last problem of assignment number 2 of principal methods and applications of nuclear tracks. And in this problem, what you have to find, the question is the radium 22688 emits a 4.60 mega electron volts alpha particle 5.5% of the time when it decays to radon 86222 Rn. You have to calculate the Q value. First of all, you have to calculate the Q value of the decay. Secondly, you have to calculate what is the recoil energy of the radon, okay, atom. So first of all, you have to calculate Q value, then you have to calculate the E recoil energy, whereas E alpha energy of the alpha particle is given, which is 4.60 mega electron volts. you know that the radium decays into radon plus emission of alpha particle. So this is the relation, this is the equation in this for this problem, because you have to find the q value. You know that the q value formula, q value is basically equals to E alpha m plus m divided by capital M, whereas small m is the mass of alpha particle, whereas capital M is the mass of residual. So E alpha, which is given 4.60, okay, and small m mass of helium, which is 4, and capital M mass of this emitted particle, which is in this case is radon, and the radon mass is 222 divided by again capital mass radon mass 222. You will get your q value, which is 4.68 mega electron volts. Now finally, what you have to calculate, you have to calculate the e recoil energy. As you know that q value is basically the sum of recoil energy and the sum of alpha particle energy, because you have to calculate the recoil energy. So recoil energy becomes q minus alpha particle energy, okay, q minus e alpha. Q you already find, which is 4.68 mega electron volts, and e alpha is already given here, which is 4.60. After putting the values 4.68 mega electron volts minus 4.60 mega electron volts, you will get your energy recoil, and that is equals to 0.08 mega electron volts. So this is how you can find the q value, and you can easily find the e recoil energy by this relation. So that's all for this assignment number 2 of principal methods and applications of nuclear tracks. If you have further questions, you can leave the comments below. I can definitely answer your questions. If you have detailed questions, you can just drop your mails. I can definitely answer you there, okay. So that's all for today. We will upload more lectures for this course of principal nuclear tracks. Till then, take care and stay tuned with us. Allah Hafiz.